So we are going to find the rational zeros of a polynomial using synthetic division, graphing calculator, and or the quadratic formula. We're also going to graph a polynomial function by finding the rational zeros and the local max or min of a polynomial function. All right, so basically this one here is what we've already done here. You typically have a polynomial here. It's either factored or it's not factored. And if it's not factored like that second one there, then we'd go ahead and factor that and get it to look like that first one. And then we'd find our zeros. In this case, we came up with 2, 3, and -4. You're used to doing those, and then you could plot those. We're going to be looking at ones today that aren't necessarily, when you look at them, are factorable right away. So then how do we find the zeros of a polynomial like that? The first thing we're going to do is we're going to use our graphing calculator and see if we can get those positive, negative whole numbers there and find those zeros. And then there's going to be some that show up there and you're not going to be able to tell what in the world those are. So then we're going to use synthetic division to evaluate the polynomial at each of those zeros. And when the remainder is 0, you found a 0. Then we're going to use the q of x there when dividing to find the next factor. And then we're going to keep repeating those steps until we either get it down to a quadratic, and then we can use a quadratic formula, or we get it down to a polynomial that factors easily, and we can get the remaining zeros that way. So something to note about this is that all of our answers must be exact. There's no rounding. When I say exact, I mean that if it's the square root of 2 and the negative square root of 2, I want you to write that down. If it's a square root of 3 and the negative square root of 3, then that should be it. If it's 2/3, it's 2/3. I should not see a 0.67 for 2/3 instead. We don't want any rounding answers. We want exact solutions. For the square root of 3, we don't want you to say that's 1.73. We want the square root of 3. So let's go ahead and let's look at an example here. So we're trying to find the exact zeros there. So notice they're looking at that one. I'm thinking, oh, I cannot factor that, so I need my exact zeros. So I'm going to go ahead and look on my graphing calculator here. So let's do that. So bring up your graphing calculator. If you don't have one, then you're using Desmos. Or you downloaded the app on your iPad there. So let's plug that in there. We're going to go to let's go to our window and make sure we're all set up here. -10, 10, 1, -10, 10, 1. And then the bottom stuff doesn't really matter. And then let's also check your table set there as well. It doesn't really matter what you start there at as long as that's a positive, negative whole number. But the increments on your table there, we want those to go by ones. So let's go to our y equals. And let's plug in a function. It goes x, caret key, 3. I have to use my right arrow to get it back down. Minus 3x. And then plus 2. Hit graph. And so it's looking there at one of the x-intercepts there is looking to me like it's there at -2. And my other one over there is looking like it's bouncing there at 1. All right, we can double check. Let's check the table there and see if we've got a -2 and a 1. So I'm going to go second table there. And I'm going to scroll up. Oh, yep, -2, 0. That's at the x-intercept. And then I'm going to look there. Oh, yeah, 1, 0 is another x-intercept. So that is true. So using our graphing calculator, we found out there that our 0 there is x equals -2, and since it went through -2, it has a multiplicity of 1. And then x equals 1, but it bounced at 1, it came down at it and then bounced back up. So that is a multiplicity of 2. So then that's how we did that. We found that on the graphing calculator there. And again, if I went through the steps there, I would go to graph, I would enter my function in there. And then I could use my table there to find my values there. All right, so then let's look at this next example here. This example here, we have to find these zeros here. So let's go ahead and let's check to see on our graphing calculator if any of those appear. So I'm going to my y equals here. I'm going to plug in my function here. And notice I have to use my right arrow there to bring it back down. And then plus 23x. And then plus 10. So x to the fourth minus 5x to the third minus 5x squared plus 23x plus 10. I'm going to hit graph. All right, so let me erase this one from last time. And let's look there. So it's looking like we're going through -2. And then I'm not sure about that next one. That's kind of in between 0 and -1 there. And then I'm not really sure about the one in between 2 and 3 over there. And then it looks like I've got one over here at 5. So I'm seeing for sure that I have one there at -2 and at 5. And both of those are going straight through those, so there's a multiplicities of 1. So let's write those down. All right, so then we also could tell on there that we had another x equals. The other ones also went through there. If you look at your other ones on that on the graphing calculator there, we can see that we've got two other ones there that are going straight through that. They're not bouncing there or forming that kind of a cubic function through that. So we know we've got another one, another 0, and then another 0. And we know they have to add up to be 4 because we've got an x to the fourth there. So we've got 2 of them there for sure. We need to find the other 2. So what we can do here is, since we can't find them on our graphing calculator, now we can go ahead and use synthetic division there. So what you do is you take those zeros and you put them in a little box for your synthetic division. You write out the coefficients there of the polynomial there. So what's in front of x to the fourth? 1. What's in front of x to the third there? -5. What's in front of x squared? -5. What's in front of x? 23. And then our constant there is 10. So bring down the first term. Take that first term of 1 and multiply by what's inside the box, which is a -2. Add those together, you get negative 7. Take negative 7, multiply by what's in the box. Add them together, you get 9. Take 9, multiply by what's in the box, negative 18. Add together, we get 5. Take 5 times negative 2 there, we get negative 10. Add together, we get 0. All right, so if I were to put my, so that means because it's basically like we just went ahead now and divided that whole thing there by x plus 2, because negative 2 there is a 0, and we get the polynomial down to 1x to the third plus negative 7x squared plus 9x plus 5. All right, and so really, if you were to multiply that out, you'd get right back up to the polynomial there. Well, that we already know that negative 2 there is a 0. We already found that to be. So now take the other 0 there, because we can't use the quadratic formula on that x to the third minus 7x squared plus 9x plus 5, nor can I factor that. So I'm going to use synthetic division there again. I already know another 0. It's 5. So I'm going to put that inside the box. I'm going to use the new coefficients of what we just found, that x to the third minus 7x squared plus 9x plus 5. I'm going to use those coefficients. And let's calculate the math on that and get that down to a quadratic. So again, use your synthetic division, bring down your 1, multiply by what's in the box, add that together, you get negative 2, multiply by what's in the box. Add that together, we get negative 1, multiply by what's in the box. Add that together, we get 0. So remember what that means. At the end here, you're going to drop down. You went from x to the third up here. You just divided by x minus 5 here. So now you're down to 1x squared minus 2x plus a negative 1. So let me write this out. So basically we're down there to x squared minus 2x minus 1. So can we factor that any farther? No, I can't factor that, so I'm going to use the quadratic formula. So doing so, we're doing y equals x squared minus 2x minus 1. So my a there is 1, b is negative 2, and c is negative 1. Opposite of b, plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. So doing so there, negative 2 squared is 4, minus a minus becomes a plus 4, which is an 8. Break down the square root of 8 there is the same thing as the square root of 4 times the square root of 2. All right, now this is the tricky part. You have to be able to, in order to break this one down and simplify this any farther here, all 3 numbers need to be divisible by the same number. So those 3 positions need to be divisible by the same number. Are they all divisible by the same number? Yeah, they're all divisible by 2, so let's reduce them all down by 2. 2 goes in each one of them one time. You can't go inside the square root because it's inside the square root, and the other ones aren't inside the square root. So then our last 0 here is x equals 1 plus or minus the square root of 2. So really, our other two zeros there are 1 plus the square root of 2, 1 minus the square root of 2. Going back up there, we had x equals -2, and we had x equals 5. And remember, they just went straight through each of these, so each of these has a multiplicity of 1. Whoops. That is our solution. Those are our 4 zeros. Notice we didn't round 1 plus the square root of 2 and put that in our calculator and then round that out to a decimal point. Nope. We have an exact solution. That's what we're looking for. All right, so now let's go ahead and let's look at this next example here. So again, we can put this whole thing into our graphing calculator here. So I'm going to clear this out of here. And again, if you wanted to, you could pause the video and try this one yourself and then come back and check. So just going to double check and make sure I typed that all in there right. All right, good. There's one, there's a bounce, there's going through, and there's another one. So I don't know, we might be able to get them all this time. Let's see. So I'm thinking this one here might be -3. It looks like it's bouncing there at 1, and then it's going through 1 there, and then there's 1 that's between 1 and 2 there. So we might just be down to 1 that we don't know. So let me check our table there to make sure. So I'm thinking we've got 1, 2, 3, 4, 5. That's a total of 5. So let's go to our table there and see what our table there says. So definitely have one there at 1 and one there at -1. And then we were also thinking that there was one there at possibly -3. So let's check the table and see if there's one there at -3. So I'm going to scroll up, and yep, there's one there at -3 as well. And so kind of looking through those, I'm going to go back to the graph here. So there is a single one there at -1. It's bouncing there at -1, so that's a multiplicity of 2. And then it's going through at 1 there, it's going through there, so that's a multiplicity there of 1. So we could go ahead and use our synthetic here division again. If you understand this already, you can just go on to your assignment there, but that's only 4 zeros and we need a total of 5 there because our highest power of x in there is x to the 5th, so we've got a total of 4 so far, we need our 5th one. So to get that one, again, I'm going to use synthetic division. Taking the constants of the polynomial, bringing my first number straight down, taking that number multiplied by what's in the box, add them together, multiply by what's in the box, add them, 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 and we got to get a remainder of 0 if we've done this right. So then we're left here with Drop down by a power, instead of x to the fifth, now it becomes x to the fourth. So now we got to take those new coefficients, put another 0 inside the box, so maybe like -1. Bring down the first 0, multiply by what's in the box, add, multiply by what's in the box, add, multiply by what's in the box, add, multiply by what's in the box, add. So now we're down to drop down by a power of x again. So now those are our coefficients. Since -1 had a multiplicity of 2 there, we can put a -1 in here again. Multiply by what's in the box. Add, multiply by what's in the box. Add, multiply by what's in the box. Add, we get 0. So now we're down to 2x squared x minus 9. That's a quadratic. So I'm going to write this out. 2x squared plus 3x minus 9. We could use synthetic division again because we still now have another 0, and we could use the quadratic. We could use that again if we wanted to. Or right now we could just go ahead and set this equal to 0. Either use your quadratic formula or try and factor this. I'm going to try and factor this time. What times what gives me 2x squared? 2x and x. What multiplies to give me 9, 3, and 3? We have to get a positive 3 on the inside, so the larger product there has to be a plus. Check your inners and outers. -3x plus 6x does give us a 3x in the middle, so there it is factored. Set each of those factors there equal to 0 and solve for x. So we already knew that x there equaled -3, but our new one there is x equals 3/2. So then we can go back up there, the top there. And our other one there is and there's our zeros. X equals 1, multiplicity of 1, so 1. X equals -1, multiplicity of 2, so that's 2 more, that's 3. X equals -3, that's a multiplicity of 1, so that's 1. And x equals 3/2, that's a multiplicity of 1, so that's the fifth one. It's a x, highest power of x, and there's x to the fifth there, so we have our 5 rational zeros. So now, if you want, you could go ahead and try out this one here as well. I'm going to move on to, I'm going to tell you what this one here is. So at -1 has multiplicity of 2. At -1/3 has a multiplicity of 1. At 2 it has a multiplicity of 1. And at 5 it has a multiplicity of 1. So check that out. Again, you could just check your graphing calculator. You get x equals -1, x equals 2, and x equals 5, and you would know a multiplicity of 2, and you could use your synthetic division, get it down to a quadratic. You'd probably put -1 and -1 for synthetic division, then try 2. Then you get it down to a quadratic, and you could factor that, and then you'll find out 5 and -1/3 are your other two. Or you could use your quadratic formula and find that as well. Let's go on to example 5 here. It says find the zeros, the local max, and the local min, and then graph it. So our zeros there, let's find them. So we could factor that if we wanted to, but I'm looking at that thinking, oh, that's not going to really factor. So I'm going to use my graphing calculator here to find our zeros. So let's do that. So you've got x to the fourth, right arrow, minus 2x to the third, right arrow, plus 2x, minus 1. Graph. Ooh, cool. So that was a little bit different there. I hope you saw that. When it graphed it out there at -1 there, it went straight through that. So we know that at -1 there, it has a multiplicity of 1. And then our other one there, hopefully you can see that there. At 1 there, it has a multiplicity of 3. It kind of did that, that cubic going through that. That's kind of a squiggly through that part right there. So that is a multiplicity there of 3. And so that does add up there to give us a 4. So let's plot those 2 points there. We've got a -1 and we've got a 1. And you might want to, in order for you to do a better graph on this, it's hard when you squash it all the way in there like that. You might want to go maybe extend out your values here. So in other words here, instead of saying that the first box there is 1, maybe I'll jump over and say the second one there is 1. Something like that. And then same thing going up. So maybe I'll do something like that so it's easier for us to graph this. So those are our 2 zeros there. And then we're going to have to find out, because it comes down, if I look at my graphing calculator there, we need to find out what that local min down there is. So remember how we can find that is we can go to second calc. We're going to go down to local min, so it's minimum on here. We want to find that value. We have to go on the left side of the point, so I have to use my right and left arrows to do that. So since my put there on the right and I need to be on the left side of the point that I want, I got to go over there, hit enter, and then I got to go on the right side of that little valley down there, the local min, hit enter again, and it should put it right there. So that's a -0.5 and a -1.688 rounded. 3 decimal places when we do those. So remember what we're going to do here. The end behavior here is it's going to be up and up, and we know that because it's a positive there. It's an x to the fourth there. It's even, and it's a positive there, so it's going to be up and up at the ends. And so then when we go through that over there, notice I kind of did that cubic. Didn't go straight through it. It didn't bounce there. It sort of did that cubic through that spot there. So that's how we'd graph that out. So I can find the rational zeros of a polynomial using synthetic division, graphing calculator, and or a quadratic formula. I can graph a polynomial function by finding the rational zeros and the local min or max of a polynomial function. So again, use your second calc to be able to find that local min or max. If it was a max, we would have done second calc and then hit max.